Alright, let's do a few velocity problems here. Traveler covers a distance of 460 miles in a time of 8 hours. What is the average speed for this trip? So average speed is going to be the speed will equal the distance, the total distance divided by the time. So this problem is fairly simple. We're just going to take our distance, which is the 460 miles. The time is 8 hours. We're going to plug these two things into this equation here. So the speed will equal 460 miles divided by the time, which is 8 hours. And you can convert this to kilometers per hour if you wanted. You just multiply by another ratio here. You just have to figure out, okay, so there's 1 mile for every 1.61 kilometers. Mile would cancel out with mile, and you could have kilometers per hour if you so choose. I think for this problem I would accept miles per hour, but if you wanted to, you could easily convert it to kilometers per hour. Let's try another one. Back on this one. Again, you can plug this into your calculator. I'm not going to do that for you. Alright, a driver drives for 2.5 hours at an average speed of 54 miles per hour. What distance does she travel in this time? So our equation is speed equals distance divided by time. In this case, we have a time, which is 2.5 hours. We have a speed, which is 54 miles per hour. And then we're looking for the distance. So distance, what is that? Let me scroll down a little. What is the distance? Alright, so I'm going to rearrange this equation to solve for my distance. So if I multiply both sides by time cancels with time. So if I take the time times the speed, that should get me the distance. Let's see. Let's plug this stuff in. So time, 2.5 hours, times the speed, which is 54 miles per hour. Would that give me a distance? Let's look at the units. Hour divided by hour, that goes away. So if you just take 2.5 times 54, that should give you the miles. And we wanted distance. Distance is measured in miles. So that would be good to go. Just plug in your calculator, 2.5 times 54, and there would be your answer. Alright, let's try to fit another one in here. Starting from rest, a car accelerates at a rate of 4.2 meters per second squared for a time of 5 seconds. What is its velocity at the end of this time? Oh boy. Alright, so this is no longer velocity, this is acceleration. So the one equation you have for acceleration is the acceleration is equal to your final velocity minus your initial velocity divided by time. Okay, so in this we have an acceleration. So we have acceleration, 4.2 meters per second squared. We also have a time, just 5 seconds. We also have starting from rest. Oh, so my VI, for starting from rest, my initial velocity is 0 meters per second. And it's asking what is the velocity at the end of this time. So we're looking for VF. If we're looking for this, that'd be VF. And we'll find it in meters per second because our acceleration is meters per second squared, our time is seconds, so it's going to be easiest if we just find it in meters per second. Alright, so we have the equation, we have all of our unknowns and knowns written out. Let's just plug our known stuff into this equation. Another way we could do it is to rearrange this equation and solve for VF first. Some people like to plug in the numbers. Other people like to rearrange the equation first. We'll rearrange it first. Let's just take time, both sides, multiply both sides by time. Time cancels out with time. We have A times T now. So let me transport all this. Let's take all this stuff. Let me shift it down here. Give me a little bit more room to work. Okay, so time times acceleration equals this stuff, so let me rewrite it. We have A times T equals VF minus VI. We want to get VF by itself. This is our guy that we're looking for. So let's get VF by itself. Let's add VI to both sides. That's plus. I plus VI. So we got A times T plus VI equals my VF. Alright, now let's plug in all of our numbers. We got everything rearranged. Let's plug in the numbers. So we have A is, I still don't like this. Let me highlight this stuff, drag it up just a little bit more even. Okay. Okay, so we have A is 4.2. 2 meters per second squared times the time, which is 5 seconds. And then whatever that answer is, we're going to add VI, which is 0. Oh, 0 meters per second. So anything plus 0 is going to not really change. That will equal our final velocity. Alright, so all we got to do is take 4.2 meters per second squared times 5s. Notice the s here is going to cancel out with one of these s's. So our final answer, the unit, will be meters per second. We don't have to care about, we don't have to worry about this guy out here. It's just 0 meters per second. That goes away. If it was 5, if it was 10, we would add it, but it's 0, so we're not going to worry about it. So just in your calculator, take 4.2 times 5, and that's going to be meters per second, and that will be your VF. Alright, we'll stop it there.